Okay. You should have gotten the foldable in class. This is side 1. For those techie people who like to screenshot and copy, that's side 1. This is side 2. Put a link up for you to access it in case you missed a day or in case you lost your copy. Alright? So, we're going to be talking about the laws of exponents. Multiplying, dividing, power to a power, power to a product. Let's start with multiplying. When powers have the same base, remember the base is the big number, you add the exponent, which is the little number. Dividing. When powers with the same base, we know the base is the big number. And you don't have to write this. This is just a cheat sheet for people who forget sometimes. You have to subtract. That's right, the exponent. Or, that's right, the little number. Right? Raising a power to a power. We would like you to multiply the exponents. Okay. And the power to a product, you are multiplying the exponent for each term. Very important. Multiply exponent for each term. Right, let's go inside. So we're starting here. The algebra. Okay. This right here. The algebra, if we have a number raised to the x power times a number raised to the y power, since they have the same base, I keep the base and I add the exponents. An example, a to the third power times a to the fourth power equals, I keep the base, I add the exponents, 3 plus 4, so this will be a to the 7th. Let's do the rest of the examples on here. 6 to the third times 6 squared times 6, they all have the same base. This 6, since I don't see an exponent, I know that it is a 1. So the base is 6. The exponents are 3 plus 2 plus 1. 3 plus 2 is 5, plus 1 is 6, so this is 6 to the 6th power. From there, you would solve this problem. So, in your calculator, you will put 6. Push your caret button. It's to the 6th power equals. So that would have been my answer. 46,656. Okay. Now we look here. Quantity of negative 2 squared times the quantity of negative 2 to the 3rd power. They have the same base. So I write exactly what I see. The quantity of negative 2. 2 plus 3. The quantity of negative 2. 2 plus 3 is 5. Then, if they ask you to solve it, you will go in. You will put in parentheses. Negative 2. Close parentheses. Caret. And it's to the 5th power. And hit enter. So negative 32. Alright, now I go here. Have 2a squared times 10a to the 3rd times a to the 4th. Be careful because 2 does not have an exponent, but a does. 10 does not have an exponent, but a does. And this a has an exponent. So my like terms here are the a's. So here's a way to do it. For every letter or number, you're going to draw a line in between. So between the 2 and the a, I draw a line. These stay together. So between the a squared and 10, I draw a line. Between 10 and a, I draw a line. Between a cubed and a to the 4th, I draw a line. And I put one at the end. Then I draw a box around the whole thing. Okay? You're only splitting the big numbers, the bases, not the exponent in the base, just the big number. So I have 2 to the 1st, a squared, 10 to the 1st, a cubed, a to the 4th. Since 2 is to the 1st power and 10 is to the 1st power, they're already simplified. So I'm going to do 2 times 10, which equals 20. Alright, now I can use these terms. I'm going to bring my 20 up here because I did that math. I have a to the 2nd, a to the 3rd, a to the 4th. So I have a 2 plus 3 plus 4. I bring the 20 over. 2 plus 3 is 5 plus 4 is 9. So a to the 9th. That is my final answer. All right, on to the next one. The algebra, when we are dividing exponents with the same base, is a to the x power divided by a to the y equals ax minus y. Okay? Another way to see that is a to the x power over a to the y power equals ax minus y. So either written like that or like that. Okay? Let's do some examples. I have the same base, so I take it. 8 is my base. 4 minus 2. So 8 to the 2nd power. 8 to the 2nd power is 8 times 8, which is 64. Example B. I always handle the top. So let's write a note. Simplify numerator, then denominator. So it's very important that you simplify the numerator then the denominator before you apply this rule, right? So here, if I look just at the numerator, I have 10 to the third times 10 to the seventh. If I remember this rule up here that we just did, they have the same base as this multiplication. So that's going to be 10, 3 plus 7 over 10 to the 4th. So I have 10 to the 10th over 10 to the 4th. Now I can use my division rule. They have the same base, so 10 minus 4 equals 10 to the 6th. Okay? And 10 to the 6th, 10 raised to the 6th is 1 million. Alright? Last one. Remember, you always simplify the numerator, then the denominator before you use this rule. So I can't simplify anything here. I can't simplify anything here. But you know something? I can reduce. Okay? I still need to see these as separate terms. Alright, so I got 2 and x to the 5th. I have 8 and x squared. Well, I know I can reduce this. I can reduce this by 2. 2 divided by 2 is 1. And 8 divided by 2 is 4. So I have that. Then I have x 5 minus 2. Okay? So I'm going to keep this 1/4. And 5 minus 2 is 3. Right? So you can write it this way. You can also write it this way. Either way is fine. So our note here is reduce constant numbers. Remember, if you need to see this again or watch it again, do that. Leave a comment at the bottom if you have a question, if something confuses you. All right? And we're going to stop here.